Hey, Cameron, you said you had one? What did I mean by the properties of water? Okay, what I meant by that is that waters are example of a polar molecule. Okay, so in lesson 8, where we talked about solubility and the polar nature of water, properties of water are things like it can hydrogen bond to itself, okay, which causes that cohesion or surface tension and things like that. Okay, it can hydrogen bond to other polar molecules. That's adhesion. So it can, when you see water stuck to the side of something and not sliding down or things like that. Okay, that's what I mean by the properties of water. Okay, what's a polar molecule? How does that make water do what it does? No, because I expect that you probably know those already. Yeah. Okay, other ones, guys. Don't be shy. Okay. Right. It is. It's the exception to every rule there is. Yeah, basically, water is always the exception. Because, yeah, we write it like this, and we said anytime hydrogen is listed first, it should be an ionic compound. Except in this case, where we clearly know that the bonds that are holding this molecule together are molecular bonds, okay, because the electrons are being shared, albeit not equally. That's what makes it a polar molecule. Yeah, okay, water is always the exception, which is why I would never give you a question and say, H2O is a polar molecule. That would be the right answer. A ionic, B molecular, C or D organic, whatever, right? Like I wouldn't ask you a question like that just because, well, really you could make an argument for any one of those answers. Polar molecule would be the best answer, okay, because it's actually true, right? Okay, other ones, guys. Ellie? Yes. So what that question is asking, if I'm asking you to draw a picture of an atom, so let's just say that I'm asking you to draw, well, oxygen, like we had on there. Okay, the first thing that that's asking is, do you understand how to read the periodic table? Okay, so the periodic table says that oxygen's atomic number is 8, right? All right, that means it has how many protons? 8. All right, so that would be one of the things I would probably want to see. Okay, I would either want you to draw the nucleus, or maybe draw, maybe just like P equals 8, or maybe 1, 2, 3, 4, 5, 6, 7, 8, and maybe put positive signs in them or something that you indicated you knew how many protons there are. Okay, in the nucleus. How many neutrons? 8. Okay, how do we know that? Because we took the atomic mass, 16. And we subtracted the atomic number. Whatever's left is the number of neutrons. Okay, in this case it's 8. So I would just draw 8 other circles. I lost count. Something like that. Anyway, okay. So we got 8 neutrons, and then how many electrons? 8. Okay. Now, what's our currently accepted model of the atom? The electron cloud model. Okay. Now, we could also say that Bohr is still to some extent acceptable, and if you drew the electron configurations of either one of those with the proper number of electrons, I'd say you're probably looking good on that. Okay. A question like that is basically asking two things. Do you know what structures of the atom we currently accept, and can you use the periodic table to tell me the right numbers? Okay. Okay. Other ones. How many people looked over that stuff on the weekend? Oh, good. Okay. Good. All right. So no other questions? Everyone's good with that? Okay, Cameron? Other than what I've already said, not really. We only really talked about how, well, it's just that in a polar molecule, like if we're looking at water, right, it looks kind of like Mickey Mouse. Okay? And because oxygen is more electronegative, the electrons from hydrogen, let's say that this is where you would normally find the electrons for hydrogen, instead of orbiting evenly around hydrogen, their orbit gets skewed and it ends up being like more elliptical, like this, and they spend more time down around oxygen than they do around hydrogen. That makes the oxygen more negative and the hydrogen's more positive, and so there's a charge at either end, right? Basically, a polar molecule is the electrons aren't shared equally. resulting in essentially a charged ends of each side, right? Okay. Other ones? You sure? Because you won't get another chance to ask. Okay, yeah, ask away. No, we didn't go over any others. Dalton's atomic theory is the big one, okay? Especially since you could probably use Dalton's atomic theory to help you in the explanation of 2 written response items at least. Okay, so in an explanation, if you think you can make a connection to Dalton's atomic theory, I would. All right, so if it's asking you something about a chemical reaction, talking about the 3rd and 4th points, okay, about this atoms can be separated, joined, or rearranged, but they're not turned into other things. The whole number ratio stuff, like those would be things you would probably want to mention because that really shows your ability to tie them together. Can you read it to me because I don't remember? Right, okay. So for that one, that's going to be lesson 4. Okay. And in there, we talked about properties of acids and properties of bases, and we said acids always have these ions, and bases always have these ions. Okay. So on the multiple choice stuff, I'm going to say because I know absolutely every one of those can be looked up in your notes, that's where to look it up. Okay. Lesson 4, and it's near the end because we talked about acids and bases at the very end. Okay? And you'll find the answer like basically laid right out for you. Well, I would say in one like that, certainly yes, what you've said is correct, that you would add something it's not soluble with. But you need to explain also, like, how are you going to do that? Are you going to make a chemical reaction occur? Okay, what kind of chemical reaction would that be? Why is that going to work? Like, there's some marks in there for the explanation of what it is you're going to do. And basically, the more in-depth your explanation is, the higher level of understanding you show, the more marks you're going to get, kind of a thing. Yeah? No, I don't care about dates. Mostly just, like if you're talking about, we started with this idea and then someone came along and discovered this. That means that, it didn't fit with this, so the model was changed to match. Basically, it's the process that I'm looking for as opposed to so-and-so did this and so-and-so did that. It's more the process. Okay? Why do we always change what we thought? Okay, any others? No, I don't think so. I mean, it's just because ice is less dense, right? Like it's just a density thing. But I don't think it's something that I'm testing on the test, no. Okay. Going once. Going twice. This is really unfortunate. I had like laid out about 40 minutes to do this, and we're done in about 10. Okay. How many people have done all the mole equation stuff? Okay, because that, guys, there's 11 marks out of 80 something. Okay, out of 84, I think I said it was out of, right? Okay, it's 11 marks. That's more than 10% of the test. It's like 12 or 13% of the test is on the mole equation. Okay, and how many ways are there for me to ask a mole equation question? 4, right? Okay, so we should probably know how to do those, because if we do, those are gimme marks, absolute gimme marks. All right, and you know what? I think I have a couple more examples. Maybe we'll go through another set here. So let me see. That's not that one. Okay, try this one. I'll give you a couple minutes on this one, and then we'll go over it together. All right, so on this one, this is an example of one of the easier ones, right? Okay, it's basically we're just looking for the number of moles here, so we're solving for n. Okay, our givens are the mass, 250 grams of water. Okay, because we're told it's water, okay, we can find out the molar mass. This is actually one I just know off the top of my head. It's 18.02 grams per mole. Okay, where we would go 2 hydrogens, so 2.02 plus 16, okay, which is oxygen, gives us 18.02. All right, n equals little m over big M. All right, so we'd have our 250 over 18.02. All right, so we're looking at 13.87 moles. Questions on that one? Okay, again, probably on the exam, right? You will not see the formula given to you. Okay, in the question it'll be written in name form. No, I don't think you need to write a sentence, but what I would appreciate is if on the exam you circled or put a big square around your answer. Because actually when I'm marking these, what I do is first I look for the right answer. Okay? If I know that you've got the right answer, I can kind of quickly skim your work. Okay? But if you got the wrong answer, then I can work backwards from there. It's easier for me to work backwards from an incorrect answer to find out where you went wrong than it is to start from the beginning and find out where you went wrong. Okay, so it is actually quite handy if you can put a circle or a square around your answer. If you don't, I'll still be able to figure it out. It's not going to be that much work, but okay, it does go a bit faster, especially when you get to physics 20. Like my physics 20s know they got to circle stuff because there could be a question that's got 10 or 11 steps, okay, before they get to an answer. It's a lot easier to track backwards, okay, from the end. All right. Questions there? All right. Try this one. Okay, you have 27.25 moles of calcium bromide. Okay, we're looking for the mass. I'll give you a couple minutes on that one because that's probably all you need. All right, so we got 27.25 moles, so they gave us N, 27.25 mole. All right, we're looking for the mass, that's little m, it's a question mark, and they told us it's calcium bromide, so we're looking at 40.08, okay, plus 79.90 times 2. All right, so 199.88 is our overall molar mass. Whoa. Okay, grams per mole. Okay, and on this one, you got to do a manipulation. N equals little m over big M. All right, and we're trying to solve for little m, so we multiply both sides by big M. Okay, and plug in our numbers. 199.88 times 27.25 moles. And we got 5,446.73 grams. Okay, questions on that one? Yes, if you don't have units, unfortunately, you will lose a mark because your answer will be meaningless. Okay. All right, let's go over that. Okay, so let's look at this one here. So they give us the number of molecules this time of lithium sulfide. All right, so if I know the number of molecules, I can calculate little n. Okay, so I'm going to take the number of molecules, okay, and divide it by Avogadro's number, which is essentially molecules per mole. Okay, so the number of molecules in 1 mole. Everyone follow me there? Okay, if I divide those two things, what cancels? Molecules. Molecules divided by molecules per mole. What am I left with? Moles. Is that the units for n? Okay, that's why we do it this way. All right, so we're going to have our 4.5 times 10 to the 24 over 6.02 times 10 to the 23. Okay, I'm shortcutting here, guys. Well, actually, you know what? I won't shortcut. 6.02, I can E23, and then that's got to go on the bottom. 4.5, E24, okay, divided by Avogadro's number. Gives us 7.48 moles. Alright, so now I know N. I can also calculate big M because they told me it's a lithium sulfide. So I'm going to have 6.94 times 2, okay, plus 32.06 for the 1 sulfur. Okay, 45.94, right, is my molar mass. Grams per mole. Okay, and I'm looking for moles. All right, so N equals little m over big M. So that'll be, sorry, I'm looking for mass. Sorry. Well, that's still the right formula. Okay, so I got to manipulate now for M. Okay, so I multiply both sides by big M. Okay, and plug in my numbers. 45.94 times 7.48. All right, gives us 343.63 grams. Okay, probably the toughest of them. Is it 32.07 on yours? Okay. All right, it's not going to change it too terrible much, but okay, it's 32.07. It's going to be 45.95. Yeah? What's that? Yeah, okay. 0.71. Okay. Sorry. That's what happens when I don't look it up, right? Okay. Good snag. Good snag. All right, last one. Okay, give this one a try. How many molecules of potassium carbonate? Expect to see it like that, okay, on the unit exam, written out in name form, not with the formula. Okay, give that one a try. Okay, so let's look at this last one here. All right, so we're looking for how many molecules. If we're going to find that, we first need to find N, right? Because then I can multiply N by Avogadro's number and get the number of molecules. All right, so the first thing I want to get is the molar mass. Potassium carbonate is K with CO3. This is a -2 and that's a +1, so we're looking at K2 CO3, right? And K is 39.10 on yours, right? 39.10 times 2, okay, plus 1 carbon, which is 12.01, plus 48, which is 3 oxygens. Okay, that'll give us our molar mass. So 39.1 times 2, okay, plus 12.01, plus 0.01. There we go. Okay, plus 48. All right, so we're looking at 138.21 for our molar mass, and that's grams per mole. Okay, so now I can also write down that I know the mass, 500 grams, and I can find N. N equals little m over big M, so 500 over 138.21. Okay, is 3.62 moles. All right, so now I know the number of moles. What do I do with Avogadro's number now? Right, multiply it by that, because Avogadro's number is the number in 1 mole. I have 3.62 moles, so I got to multiply. Okay, so number of molecules, okay, equals 6.02 times 10 to the 23 times 3.62. All right, so we're looking at 2.18 times 10 to the 24. Molecules. Far enough? Okay, those making sense? All right, because like I said, those are like, like I said, it's 11 or 12 marks. Okay, so it's a big deal out of an 80-some mark unit exam tomorrow, right? And okay, I fully expect that you guys are going to get all of those. All right. What do you need to bring for tomorrow? Yes, you must have a calculator. Remember that you cannot use your phone tomorrow on the exam. I will be putting your phones in a Rubbermaid bin. Okay, they will all be off so none of them vibrate or make noises while people are trying to write tests. Okay, so they'll all be up front. You need to have a real calculator. All right, if you do not come with a real calculator tomorrow, okay, you are in real trouble because I don't have any to lend out. Right, when I lend them out, they don't come back, and now I don't have any. So make sure you have one. Everyone clear on that one? Okay, what else do you need to bring? Already got calculator. That's what we just finished talking about. Oh. Yes, bring your periodic table. Remember that I will be looking it over, however. Okay, I will let you have yours as long as you haven't written too many things to yourself on it. Okay, if I find that you have written too many things on it to yourself, I will give you a fresh one. All right, so I recommend not doing that. Or if you have, that you find a way to completely remove them from the surface of your periodic table. Otherwise, you won't be allowed to use it. Okay. You also need a pencil, okay, on your exam, right? Because there's a multiple choice component, okay, and you got to fill in the little, circle deals with a pencil. Did we go over that already? Okay. This is the thing, guys. This is why I want you to use pencil. Well, I don't actually machine score it. If I did machine score it, you would have to use pencil or it wouldn't pick it up. Okay? But for me, all right, I do it. Actually, this is the one thing I do old school. All right, I make the key myself, and then I make a photocopy of it. Okay, on a piece of transparency. It's this transparent film. Okay, and I stick it on top of yours, and if our dots all line up, you're good. Okay, if the dots don't line up, it's wrong. Like if I put it on there and the row for question number 12 has 2 dots in it, I was right and you were wrong. And that's not good for you. Okay? It's very straightforward. But if you've done this, oh, it's not that one, it's this one. Oh, no it's not. It's that. No, it's not. It's this one. It's just wrong, okay? Because I'm just looking for how many dots there are in the row. In this case, there were way too many dots in that row, okay? It's wrong, all right? So, please, erase completely any correct answers, or this one will be wrong, okay? Please don't do that. Right? It's really, really annoying. Right? It just shows total indecisiveness on your part, okay, on an exam, and a total lack of confidence in your own abilities. Okay, you should have lots of confidence in your abilities. Okay, just make sure you do it that way. Now, tomorrow, just make sure you got a pencil. When I give you the test, it's not going to be stapled. Okay, I used to staple them, and then people are ripping them apart, and then they don't staple back together at the end because they've torn the corners off of all the pages. So I'm giving it to you without it stapled. All right. The other reason for that is the multiple choice form is at the end of the multiple choice, which is actually in the middle of the test, and so you're probably going to want to be able to flip back and forth. And if it's stapled, you're always going like this. Whereas when it's not stapled, you can have the multiple choice questions and the form side by side. Okay, it's a lot easier and quicker without a lot of page flipping. The concern is, don't let your pages get out of order. Because if you do, and you're doing questions 13 through 17, but you're really supposed to be doing questions 15 through 19 or whatever, it's going to mess up your order, and that's kind of important. All right, so just be aware of that one. If you want to have something to eat or drink during the test, that's fine. Okay, you can bring that in as well. Okay, don't mind that. Just don't spill it on the test. All right, but yeah, that'll be fine too. Okay, any questions about the test for tomorrow? All right, pencil, calculator, periodic table. Make sure you have those 3 things when you come to school tomorrow. All right. If you don't have a calculator, beg, borrow, or creatively acquire one. I would never say steal because that's not a nice thing to do. Okay. Beg, borrow, or creatively acquire one. Okay. Before the exam. All right. So finish up that mole thing. Okay. That's your best bet. That actually can count a little bit as you're studying for the exam because obviously the mole equation is on the exam. And there's still 20 minutes of class left. Question? Okay.